first couple of questions on the second review packet. I was hoping you were able to do a couple of these, like 1 and 3 and possibly 4, at least 2. We haven't actually done this year. We've done the math involved in it, but never a picture just like this, so we'll talk about that. The first one said find the average rate of change, which I'm sure you're sick and tired of at this point, for g of x. So let's do this. The average rate of change, again, is slope, right? Which is y2 minus y1 over x2 minus x1. Technically, it's not slope. We're not supposed to say it's slope unless it's a line. But for you guys, that's kind of the bell that must go off in your head when you're doing average rate of change. And this here would be x1. This here would be x2. And then we get y1 and y2 by plugging these in to g. So here we go. Make a big long fraction bar here. In the denominator, I'm going to put a plus h minus x1 is a. And then y2, I'm going to take this formula. So it's going to be 3 over and put in a plus h. Right? But we have to subtract 5 from that. Minus y1, which is 3 over, I'm going to put a where the x is, minus 5. Great. So basically what I have to do here is create a common denominator in the numerator. So this guy's got to get multiplied by a plus h minus 5. So up here, minus 5. And this guy's got to get multiplied by a minus 5. All right, so creating a new, so this denominator, a plus h minus a, that's just h, okay? And now, up here, I have 3a minus 15 all over the new big denominator, a minus 5, a plus h minus 5, minus, going to distribute this 3a plus 3h minus 15 all over a minus 5, a plus h minus 5. Okay. So that's my new numerator. So now I'm going to bring it down here. So the denominator is h. Right? Going to keep my denominator, which is a minus h, a plus h minus 5. But I'm going to subtract this. Now keep in mind, this minus has got to go to all 3 pieces. So 3a minus 3a. The 3a's would cancel. And then, look here, we have negative 15 minus minus. Double negative becomes a plus 15, so even the 15s get canceled. But you got to be careful here, is what left over is 3h, but this minus gets distributed to him, so it's negative 3h. All right, so now we're going to do keep, change, flip. Okay. Times flip over h. Okay. You just cancel. And I end up with negative 3 all over a minus h, a plus h minus 5. So that is the answer to that guy. All right, so that's number 1. Number 2 says, we have 18 feet of fencing is available to build 5 adjacent pens as shown below. Express the total area of the pens as a function of x. For what value of x will maximize the area? All right, well, first off, do you guys see how this is an x here? That means all the way across, all of these vertical lines, they're going to be x's as well. Like that. Okay. Now, we want to find the total area of this pen. Now, area of a rectangle is length times width. Well, we know this is x, but I don't know how long this is. So I'm going to make it y. So they're both going to be y's. So the area of this is going to be x times y. Okay. Express the total area of the pens as a function of x. Problem so far. This isn't a function of x. This is a function of x and y. So I need to make sure I get rid of the y somehow. What haven't we used yet in this question? This. 1,800 feet of fencing is available. So that means I have 1,800 feet to do all this math. Well, let's check it out. I have 1, 2, 3, 4, 5, 6. I have 6 x's and 2 y's to use up the 1800. So I'm going to use this now to get rid of the y here because I'm going to solve this for y. I'm going to subtract over the 6x. Divide by 2. When I divide by 2, I get 900 minus 3x is y. So now my area formula can become x, and where y is, I'm going to plug in 900 minus 3x. All right, so now that answers the first part of the question. Express the total area. So I'm going to put a box around that. That takes care of the first part. Now, what value of x will maximize the area? Well, let's do this work now. Put area equals, if I were to distribute this, I'd get 900x minus 3x squared. What would that look like if I graphed it? An x squared equation, specifically a negative x squared equation. This would be a sad face parabola. And if I want the maximum point, what little dinky formula would I use to do that? And it should be on your formula sheet already. And that's the axis of symmetry. Right? The axis of symmetry is going to be x equals negative b over 2a. So let's plug into that. X equals, the b would be 900, so it would be negative 900 over 2 times the a, which is negative 3. So I get negative 900 over negative 6. Negative over negative, right, is positive. So if we reduce this now, this is 900 over 6, right? They both have 3 in common, or let's face facts, you're going to have access to your calculator, so I'm going to, right? I'm getting 150. Okay, so for what value of x will maximize this? Boom, x equals 150. And that's the answer to number 2. Okay. Next one. State the domain and range of f. All right, so let's take a look at this. Domain. Basically, domain is always all real numbers unless it's a fraction or radical, right? Well, this is a fraction. What number would ruin this fraction? Negative 2, right? So that means everything will work except negative 2. So that's how we write that. Now, if we take a look at this question, it's also going to ask about the inverse. Well, the domain, right, of the original will always be the range of the inverse. So I can actually answer that right there. Okay. And the domain of the inverse will be the range of this guy. So it's actually easier if I do the inverse first to answer this question. So let's make the inverse of this guy. Right? What we have to do is switch the x and the y. So I'm going to write x equals 3y minus 1 over y plus 2. This is a fraction, so I'm going to make that look like a fraction and cross multiply. So I get 3y minus 1 equals xy plus 2x. Now, I want to get the y alone again. So I'm going to get everything with y's on one side, everything without y's on the other. I'm going to get 3y minus xy equals 2x plus 1. Factor out the y. And I get y equals 2x plus 1 over 3 minus x. Now you cannot leave it in y equals because we're using function notation. So to get full credit, you would have to write f to the negative 1 and what you got right there. All right. Now there is another version of this, depending on how you subtracted it over. If you got, let's see here, like negative 2x minus 1 all over x minus 3, that's the same exact answer. So I'm aware of that. Okay. Now, what would be my domain for this guy? What would ruin this denominator? And I hope you're thinking 3. So the domain for the inverse would be negative infinity to 3, or 3 and up, which would give me the range for this guy. So you guys don't have to answer the parts in order if the other sections will help you out. Okay, now let's move on to number 4. All right, sketch the graph of this guy. First thing we got to do is factor. So up here factors into x squared minus 1, x squared plus 1, which can obviously keep going. This factors into x minus 3, x plus 2. So factored, I would have x plus 1, x minus 1, x squared plus 1, all over x minus 3, x plus 2. So your job is to completely factor this stuff before you jump into it. Now we go one step at a time. Zeros. Zeros and x-intercepts are the same thing. And that's if you look at the numerator. What would make the numerator 0? Well, that guy would be negative 1, 0, and this guy would be positive 1, 0. There's no way you can make an x squared plus anything 0, so we only have the 2. Okay? Then we want to get the y-intercept. The y-intercept is when you plug 0 in for x. So if I plug 0 in for x, I get negative 1 on top and a negative 6 on the bottom. So that makes 1/6. Then we want the vertical asymptotes. All right, so that's when you look at the denominator. What would make the denominator 0? That would be 3. So x equals 3. X equals negative 2. And it's always an equation. You just can't put down the numbers. That would be wrong. Okay? Now, the horizontal asymptotes, usually there's only one at your level. That would be the long-run behavior. So guys, if I use the words long-run behavior, it's the same thing as the horizontal asymptotes. It tells me what's happening on the far edges. We're going to do our limits. So the limit as x approaches positive infinity. Okay, look at the original. What's the most powerful thing in the numerator? X to the 4th, right? What's the most powerful thing in the denominator? X squared, which would reduce to be x squared. Now, is that a number? No, it is not. So that means there's going to be none. Because the same thing would happen if you did negative infinity. So there isn't going to be any horizontal asymptotes. What this does tell me is in the corners of the picture, it's going to flare out like a parabola. All right, guys, so now we can graph these things. So here we go. Vertical asymptotes, so we've got negative 1, negative 2. You should put the numbers on here. So that's going to be a vertical asymptote. We know at negative 1, 0, there's a dot. Positive 1, 0, there's a dot. 2, 3. There's another vertical asymptote. Okay. So here we go. We're going to start filling in some blanks. I have no idea what's going on. Oh, and I forgot this guy. Right there. Okay. So start out here. Let's plug in the number 4 to see what's going on. So if I plug 4 into this, I'll do it up here. If I plug 4 in, I get 5, 3, 16 plus 1 is 17, right? 4 minus 3 is 1, 4 plus 2 is 6. All right, so all I care about really is this answer going to be positive or negative? It's going to be positive up here somewhere. So what that means, right? Now, I cannot go down at all. I cannot go down because the only place I'm allowed to touch the x-axis are here. So that means it's got to stay up here. So over here, it's going to hug this guy. And remember the x squared that we got? That means over here, it's kind of looking like a parabola. So it would look like that. Now, over here, I know I have to hit these 3 dots. So I'm going to connect them. All right, now, go back to here in the factored form. What exponent do these guys have on them, right? These both have 1s. 1 means they're going through the point. So it means I have to go through him and through him. Okay. Now I need to know what's happening over here. So now I'm going to plug negative 3 into this. I'll put it down here. Negative 3 plus 1 is a negative 2. Negative 3 minus 1 is a negative 4. Negative 3 squared is 9. 9 plus 1 is 10. Okay. Negative 3, that makes negative 6. And negative 3, that would be negative 1. So up here, it looks like it's 80. And down here it's 6, so it's another positive number. Again, we cannot cross over the x-axis, so we have to stay up here. So I'm going to hug here. And again, it's got to look like a parabola over there. So there you go, guys. Those are the first 4 questions of packet number 2.